Place each figure in a coordinate plane in a way that is convenient for finding side lengths. Assign coordinates to each vertex. Part A. A scalene right triangle. A scalene right triangle is a right triangle, which means it has a right angle, with no equal sides and no equal angles. Note that it is easy to find lengths of horizontal and vertical segments and distances from the point 0, 0. So place one vertex at the origin and one or more sides on an axis. So place your first point at the origin, 0, 0. Since it's a right triangle, you will have one point on the y-axis and one point on the x-axis to form your right angle. So let one coordinate be 0, b, and another be a, 0, where a and b are not equal. Then connect your points using line segments to form your scalene right triangle. Part B. Isosceles trapezoid. An isosceles trapezoid is a trapezoid where the leg lengths are equal. In order to do this, place your base on the x-axis. So start with the point -c0 and then point c0 because it would be easy to find this length. Let your other 2 points lie on the same line through the y-axis. Say -AB and AB. And then connect your points using line segments. Notice it would be easy to find the line segments because 2 of your lines are horizontal, and you know that the other 2 legs are equal because it's an isosceles trapezoid. Write a plan for a proof that uses the SAS congruence theorem. Given the coordinates of vertices of triangle POS and triangle ROS, prove that ray SO bisects angle PSR. Use the definition of perpendicular lines to show that angle SOP is congruent to angle SOR, because the x-axis is perpendicular to the y-axis. Use the distance formula to show that PO equals RO. Use the reflexive property of congruence to show that line segment SO is congruent to line segment SO. Then use the SAS congruence theorem to show that triangle POS is congruent to triangle ROS. Then conclude that angle PSO is congruent to angle RSO. That implies ray SO bisects angle PSR, because ray SO splits angle PSR into 2 congruent angles. Place an isosceles triangle on a coordinate plane with vertices P negative 2a0, Q0a, and R2a0. Find the length of each side. Then find the coordinates of the midpoint of each side. Begin by placing your vertices on the coordinate plane. P negative 2a0, Q0a, and R2a0. Then connect the points using line segments. Next, find the length of each side. Notice that because this triangle is an isosceles triangle, PQ will equal QR. Using the distance formula, PQ equal QR is equal to the square root of the quantity negative 2a minus 0 squared plus the quantity a minus 0 squared. Simplifying gives the square root of negative 2a squared plus a squared, which simplifying again gives a times the square root of 5. Then PR equals 4a because 2a minus negative 2a equals 4a. Next, find the coordinates of the midpoint of each side. So the midpoint of line segment PR is 2a minus 2a divided by 2, 0 plus 0 divided by 2, which equals 0, 0. And the midpoint of line segment QR is 0 plus 2a divided by 2, a plus 0 divided by 2, which equals a divided by 2. And the midpoint of line segment PQ is negative 2a plus 0 divided by 2, 0 plus a divided by 2, which is negative a divided by 2. And then you can plot these points on the graph and notice that they are indeed the midpoint of each line. Write a coordinate proof. Use the diagram and the given information. Prove that angle TOU is congruent to angle VUO. The slope of line segment TO is k minus 0 divided by m minus 0, which equals k divided by m. And the slope of line segment UV is k minus 0 divided by m plus h minus h, which equals k divided by m. So because line segment TO and line segment UV have the same slope, then line segment TO is parallel to line segment UV. By the alternate interior angles theorem, angle TOU is congruent to angle VUO. Because looking at the diagram, these two angles are alternate interior angles because they lie on opposite sides of the transversal and inside the two parallel lines. As part of a graphic design, you draw a rectangle and then connect the midpoints of the sides. Prove that the quadrilateral MNPQ formed has 4 congruent sides. First, find the coordinates of the midpoints. The coordinates of M are 0a, and the coordinates of N are B2a, and the coordinates of P are 2ba, and the coordinates of Q are B0. Now find the lengths of each of the sides. Using the distance formula, Mn equals the square root of the quantity b minus 0 squared plus the quantity 2a minus a squared, which equals the square root of b squared plus a squared. Using the distance formula, Np equals the square root of the quantity 2b minus b squared plus the quantity 2a minus a squared, which equals the square root of b squared plus a squared. Using the distance formula, PQ equals the square root of the quantity 2b minus b squared plus the quantity a minus 0 squared, which equals the square root of b squared plus a squared. Using the distance formula, QM equals the square root of the quantity b minus 0 squared plus the quantity 0 minus a squared, which equals the square root of b squared plus a squared. Because the line segments have the same length, the 4 segments are congruent.